All right, welcome to class, everybody. Sorry we got a little bit of a late start on that. Just getting everything set up. So this lesson is the last lesson that will be on your Unit 1 test. So tomorrow is a homework day, just like every Tuesday. And then on Wednesday, we'll be doing the review for your tests. And you can take the tests in the testing center on Wednesday, Thursday, or Friday. And all of your Unit 1 assignments have to be submitted by Friday. So if you have any late work from Unit 1, make sure it's finished by Friday because you won't be able to use late passes after that point. And that's just from section 4.4 previous. Anything that we do on Wednesday and Wednesday's the review, but on Thursday and Friday, we'll be starting Unit 2. So you can use late passes on those. But anything from section 4.4 or before will close on Friday. Any questions about the tests or yeah?
So will you come in here on Wednesday then at 2?
Yes, I mean, if you want to review for the test. So I'll be going over any questions that you guys have on the practice test. But I mean, if you took the practice test and you're like, oh, I know everything, then I guess you don't have to come, but that's what we'll do in class. Yeah, any other questions?
Then we do have class Thursday and Friday.
Yes. Mm-hmm. Yep.
Some teachers on the days of test, because it's the days
Oh,
of test, we don't have class, so you have time to take the test.
Gotcha. Yeah, no, we'll still have class on Thursday, Friday. Yep. Any other questions? All right, then let's. Yes. Mm-hmm. Yep, and you will not be allowed to use notes. So like it's just scratch paper and the test that's given, but I will give you the formulas and the form that like essentially what you'll see on the test, that's on the practice test. So if you look at the practice test, you'll know what formulas will be provided. Yeah.
I'm sorry, I'm new, but with the test taker, do you have to set up on your campus, or do you just walk in and say?
I think you just walk in. I mean, I've never done it, but I'm pretty sure you just walk in and you scan your card. And like sometimes they're busier than other times, so sometimes you have to wait a little bit. But yeah, you should be able to just walk in. Is that not the case? Does anybody know?
Yeah, you just walk in there. I think you gotta be there before 5 to take the test too.
Yeah. Yep. Because I don't know what time they close and it changes depending on what day it is. Yeah. So, okay, cool. So let's go ahead and get into this section. So this section is about finding solutions to systems of inequalities. So this is very similar to finding solutions to systems of equations. The only difference is that with systems of equations, you know, when we talked about graphing them, the solutions to a single equation will look like a line, and then the solutions to a system will be where the lines overlap. So with inequalities, though, remember inequalities are graphed as lines that are the boundary lines, and then you shade one side or the other. And so a system of inequalities is going to have an infinite number of solutions instead of just a single intersection point, because their shaded parts will overlap. So as an example, let's look at this one. So if we wanted to find a solution to this system, we need to have points that make both of these inequalities true. Because a system is a group of multiple math statements. And so for this one, if we wanted to find the solutions to this system, we would start off by graphing the inequalities separately. So I would say, okay, well, y is greater than or equal to 3x plus 1. I can graph this by graphing the boundary line, which is where y will equal 3x plus 1. And that equation is in slope-intercept form. So I know that I'm going to have a y-intercept of 3. And then my slope is, a y-intercept of 1. And then my slope is 3. So I'll go up 3 and over 1. And you could also get this point by plugging in x equals 1. And if x equals 1, you'd have 3 times 1 is 4, or 3 times 1 is 3, plus 1 would give you y equals 4. But I like doing it with the slope just because that's what I'm familiar with. So these 2 points are solutions to the equation y equals 3x plus 1. And this equation is the boundary line for this inequality. And should this boundary line be a solid line or a dotted line? Call it out. Yep, perfect. So we'll have a solid line because this inequality has an or equal to sign underneath it. So that's how we know that it's going to be a solid line. Because essentially all of the points along this line will make this inequality true, because these points are all the places where y equals 3x plus 1. But that will still make the statement true because this inequality says they could be equal. So that's the boundary line. But all of the solutions that make the inequality true are going to also include some of the points on one of the two sides of the line. So you can choose what points you want to plug in to see which side to shade. And I like plugging in zeros because I think that that's an easy point to plug in. So I'm going to plug in 0 for y and 0 for x. So when I do that, I get 0 is greater than or equal to 3 times 0 plus 1. So I'm testing to see if this point is a solution or not. And when I plug it in, it makes a false statement because 0 is not greater than 3 times 0 plus 1. And so that means this is not a solution, which tells me that my solutions will be on this side. Is everybody good with that? That's kind of a review of stuff we've already done. So really the only new thing we're doing is the fact that we're graphing a system. And so to graph the other equation in the system, I'm going to graph y equals negative 2x, which has a y-intercept of 0 and a slope of negative 2. So I can go down 2 and over 1. So these 2 points are solutions to the equation y equals negative 2x. And the line that connects them will be all of the solutions to y equals negative 2x. So the points on those lines, if I plug them in, will they make true or false statements for the inequality I'm trying to graph? False, right? Because if these two things are equal, then this is not less than this. And so what does that mean in terms of the type of line I'll draw? Yep, I'm going to draw a dotted line. So my boundary line is a dotted line, which means the points on the line itself are not solutions. And then I need to determine which side to shade. So in this case, plugging in 0, 0 is not helpful because it's on the line. So I'm going to plug in some number on one of the two sides. So maybe I'll take this point right here and I'll say, okay, if x is 2 and y is 1, does that make a true statement? So I'll say 1 is less than negative 2 times 2. Is that a true or a false statement? False. So that means this point is not a solution, which tells me that all of my solutions will be on the opposite side. So this blue shaded area is all of the solutions to this inequality. So the solutions to the system of inequalities are basically all of the points along this dotted line, the solid line, and then the overlap between these two areas. So all of the points in here will be a solution to the system. So hopefully that's not too complicated because it's basically just kind of doing two copies of what we've done before and then looking at where the overlap is. So let's do a check-in really quick. Scale of 1 to 5. How are you guys feeling about this? Okay, cool. Are there any questions on this? Yeah.
Is that the only way to show the solution is just graphing a fold and then finding where the shading overlap?
I mean, like if you just wanted to find a single solution, you could guess and like find one, but this is the only way to represent all of them because there's an infinite number. Like this graph keeps on going forever. So there's like a quarter of the entire, any possible order pair you could have will make that system true. Yeah. Any other questions? Okay. So I want to go through a couple special situations just so that you guys know how to graph them. But first, just a reminder, this is from a previous lesson, but just remember a dotted line is like the two-dimensional version of an open circle. A closed line is like the two-dimensional version of a closed circle. So if that helps you remember like when to do a dotted line versus when to do a solid line, that's just kind of a helpful little connection. Okay, so let's say that you are asked to graph something, a system like this. So the process is the same regardless of what system you're graphing. You're going to graph the boundary line and then shade one side or the other of the line. The only thing that makes this a little bit different than the one we just did is the fact that the inequality only involves a single variable. But if we remember, the way that we graph something like y equals -1 is that it's going to be a horizontal line that includes all of the points where y equals -1. And it's a solid line because it's less than or equal to. And then if I think about all of the points where y is going to be less than or equal to -1, well, it's things like y is -2 or -3 or -4. And so that means that I would shade this area of the graph. And then you do the same thing for x equals 3. Show me with your arms, what's x equal 3 gonna look like? Yep, and is it gonna be dotted or solid? Yep, dotted. So we'll have a dotted line right there. And then will I shade it to the left or to the right? I think I heard someone say right. That's correct, because that's where all of the x's are that are greater than 0. Because the thing we're trying to make true is that x is greater than 0. So the solutions to this system are going to be all of the points in this little section right here. So that's how you would graph something like that. If you have one like this, what it's basically saying is that it's all of the y values between -1 and 4. So it's kind of like all of these values in here. When you graph this on your homework though, you have to graph it as like 2 steps. So you would graph like this line and shade it upwards, then you would graph this line and shade it downwards. And the place where they overlap is where this statement is true. And then you do something similar for the second statement where you'd say x can be -6 or 4 or anywhere in between. And so you would shade that range. And so the solution to the system would basically be all the points in this rectangle here.
So like on the test and just in general, do you just want us to shade the solution to the whole system, like just where they overlap, or do you want like?
So I mean, I would be fine with it if you just shaded this solution part. On your test, I think there is one question like that. And the way that I would like it to be shaded is like, let's say you have your lines like this, just like shade it in 2 directions. So like shade it kind of like this for one of them, and then like shade it like this for the other one so that it's clear that there's 2 different shadings going on there. Yeah, good question. Any other questions? Yeah. Paper. Yeah. Any other questions?
You went over that very, very fast, that question.
This one? Okay, would you like clarification on any of it?
Yes. By the time I was done writing -1, you had everything done, so.
Yeah. So essentially what this is it's kind of like 4 different inequalities. So like this one is saying y is greater than -1. So you would shade everything above where y is greater than -1. And then y is less than, or actually that should be a dotted line. I made a mistake on that. So this should be a dotted line right here because it was just less than. And so you would have y is greater than -1, but you also want it to be less than or equal to 4. And so this blue part represents this inequality. And then the red one, I also should have a dotted line right here. And that's just saying that's between -6 and 4. And on your homework, you're gonna have to graph those as separate lines just because of the way your graphing tool works. Yeah. Any other questions? Okay. So let me just do like a quick recap of how to graph the different types of equations. So if you have an equation like this, where you have x and y on the same side of the equation, that's standard form, and it's usually easiest to graph standard form equations by finding the intercepts. So like in this case, you would say if x is 0, then y would have to be 5, and if y is 0, then x would have to be 5. but sometimes X and Y might be multiplied by numbers, which might change your results slightly. But that's usually the easiest way to graph the standard form equations. So like on this one, we'd say, okay, 5, 5, and then it's gonna be a solid line. And would I shade this, the lower part of the graph or the upper part? I think I saw a couple people say it'd be the lower part because, like, let's say I take the point 0, 0. If I plug that in, 0 plus 0 is less than or equal to 5. So this point is a solution, which implies that the entire side of the graph is going to be a solution. Then for this type of equation where you have y equals 2x plus 6 as your boundary line, if that's in slope intercept form, then you can just use your intercept and then use your slope. So my intercept would be 6 and my slope is 2, which I could think about as going up 2 and over 1. But that would be off of my graph. So I could also choose to go down 2 and backwards 1 because -2 divided by 1 is also 2. And that would be on my graph. So that gives me that point. This would be a dotted line. And then on this one, I could plug in any point, but I would probably plug in 0, 0. And I'd say, is 0 less than 2 times 0 plus 6? That is true because 0 is less than 0 plus 6 because 6 is a positive number. And so that means that this point would be a solution. And so this red section would be the solutions to that inequality. And there is one homework problem on your homework where you're given 3 inequalities that you need to graph. And so you could also do this last one and say, well, if y equals -4, that's going to be the line at that shows all of the points where y is -4. And I did a solid line because it's greater than or equal to. And all of the y's that are greater than or equal to -4 will be the ones that are above it. And so I would shade this part of the graph right there. And so essentially the solution to this system is all of the points in this little triangle space right here where they're all overlapping. Because if you have a system of 3 inequalities, they all have to be true in order for the system to have the solution. So those are some of the key examples I wanted to go over just to help you guys with your homework. There was one question that a lot of people asked on the homework, and it had to do with like having something like y is less than x. So you still graph it the same way. You graph the line y equals x, and the line y equals x is going to be a perfectly diagonal line that goes through all the points where x and y are the same, like 1, 1, 2, 2, 3, 3, 4, 4, etc. So I think it was just maybe such an easy equation to graph that they weren't sure how to graph it because it was too, like it didn't have any numbers. So I think that's everything you guys need to know for your homework. So if you want to pull your computers out and start working on it, you're welcome to do that. And I will answer any questions you have.